Hi, so we're taking a look at this demo of how you can do real-time data streams and use them in various ways in a real-time data context and store them in your DB2 data stores for permanent storage and rich analytics. So we're going to start off in NiFi. I'm ingesting data from the US travel advisories. This data is coming in a format of RSS of XML. Not the easiest thing to work with. I'm going to use SQL to convert it into JSON with a schema. Using a schema, I'll know the types, names of fields, are they nullable? These are very important things when you're working with data. I'm going to reformat this data, add the fields that I need, including a unique ID and a timestamp, and make this data available to anyone who needs it, including Kafka, including Flink, and including, very importantly, DB2. So I ingest this data. As you can see, the data is coming in really quick, and I paused it so we could see this happening and we don't just see the data blaze by and not realize we have data loading. This is running in a small context that could be scaled out into hundreds of nodes if necessary. This is just running on my laptop. So we're sending data to DB2 really easy. Don't have to write the SQL, don't have to know the fields because we have a schema and the table has a schema. I've got a connection pool that connects me to my DB2 instance. I use my driver. It maps it for me, does all that SQL checking, storing that data into DB2. That's awesome. And then when I want to query it, just as easy. I'm just going to grab from this travel advisory table that matches our travel advisory schema. Then we can get the data back from that same data store. As you see, came quickly. Let's see how many rows we got back so far, and 5,000 rows. Pretty easy. And here I could store them somewhere else, maybe in my iceberg table that we're using in our joint IBM Cloudera data store. Lots of other options. Also, I mentioned we have that data going into Kafka, and it's in Avro, which is a binary format that makes it more compressed, easier to send and work with. And you can see I've got my data here visible to me, and I've got just came in, just loaded. And at the same time, I can run a live query here with Flink SQL. It looks like regular SQL, but the thing we'll notice is that it is real time. This is joining data as it comes into the stream. So as quickly as an event comes into a Kafka topic, it is available for query within Flink. And that is one of the many ways we could do real-time streaming analytics. From here, I could have done an insert into another topic or right into a data store like DB2 or into iceberg tables, wherever it makes sense for this particular application. And I could do things like union them, join them, connect this to other sources of data, pull up data from other systems. One thing that I'm doing is creating a materialized view so I can use this in some analytics. And you see it automatically generated a REST endpoint for me based on this data. And if I want to have my data scientists explore it, I can have them open up any data science notebook. This one's Jupyter. It'll also work within Watson or in Cloudera ML, any machine learning, very easy to integrate. I don't need any special drivers. I connect, it could be over SSL, get my data in JSON into a Panda, shows me all the fields, and I could explore it. Now I could start using this to maybe train some models or do any other kind of analytics I might want to do with a notebook while not taking it out of the stream. It is still a live data stream coming into the system real time. And at that same time we're doing that, it is going into DB2. We're getting more data, and I can get that data out, push that to an iceberg table, or join them together as part of some analytics. very easy to do. Just to show you this live as it happens, very straightforward. Data from wherever it is in the world, cleaned up, reformatted, enriched in NiFi, pushed into a Kafka topic to be distributed to whoever who needs it, whether that's Flink, whether that's another NiFi process that's going to push it into DB2 or Iceberg, whether that's directly into a Kafka Connect, maybe dropping it into Iceberg or S3, wherever it needs to go, and then have it available for any kind of machine learning or deep learning analytics that need it.